Well, thank you all for joining me today. So, I've got a pleasure to speak here at the Microsoft Ignite conference, and I think it's a big honor. I'm actually a recent Microsoft MVP with them for the data platform space. What my topic and what I'm going to be covering today is really focused on what you need to do to start to utilize Cortana Intelligence Suite to really architect full solutions. And when I think of full solutions, I think of things as any big data problems you start to have, any Internet of Things devices that are driving new data and new ways of looking at data. There's predictive learning and machine learning. That's a new, not necessarily new in the terms of what we've been, machine learning's been around for years, but it's new in the way of being able to scale in new ways, using cloud platforms, using different ways to do that. Now, just to give you a little background of myself and who I am, I'm Tom Merrick. As I'd mentioned, I'm an MVP. That's what gave me one of the honors of speaking here today. I'm a practice director of enterprise solutions at SATA Systems. My focus there covers anything from custom development, anything in IoT, machine learning, data and analytics, and also portals in Office 365. We are very focused on Azure across the board, and as you see with my role, it really covers all of those areas. Now, an objective today of what we will be covering. Mainly, I'm going to start with kind of looking at the business versus IT. A lot of the times, the challenge that comes across first is that business use case. Gathering up the business use cases and a reason why you're investing in this new technology, this new way of doing things. When you start to look at why, that's a huge factor here. Just going out to do big data is not going to fly for very long. But if you have a good solid use case to fit into this need, that's where you're gonna really drive that change in your organization. And it will be transformational for you. It'll focus on big data, the Internet of Things, and machine learning, and ways that these are starting to come into certain verticals. And I'll be very generic and very high level with those, and feel free to come up and talk to me afterwards if you want to dive deeper in any of these, or in verticals that I'm not covering in this session. Feel free to come up to me. I'm going to also correlate these to technical use cases. How do these verticals start to correlate to those technical use cases, and how do we come together as a business and an IT team to ultimately deliver value to your business? I'll break down the services in the Cortana Intelligence Suite, and not only will I break down each of those components in there, but I'll also go through a quick demo of a few of them to show you the auto scale features and how to build a quick machine learning model. Things along those lines that we'll just do really rapidly and quickly during this session. And then lastly, I'm going to go through some technical use cases and reference architectures. So it's going to tie those technical use cases back to reference architectures, and what objects and what services do you need inside of Cortana to spin up this service end to end. Some of them are hybrid, some of them are completely cloud-based. Just depends on where your data is coming from. So, now business versus IT. This has been, kind of getting more and more contentious, and one of the reasons for this is there's more and more backload of work for IT. There's more and more self-service tools. There's things along those lines that are driving change in the way that the business works with IT. Also, a lot of the times budgets. Where do budgets come from? A lot of the times that's coming directly from the business, not from IT today. Business's perspective on this is really, we have this new data. So what are we going to do with it? And this could be telematics data. It could be data coming from a manufacturing plant floor. It's usually not your typical CRM, ERP, standard relational systems that are kind of been in the organization for years. These are oftentimes external feeds or new internal feeds that are generating tremendous amounts of data. Now, Cortana could definitely handle the classic data feeds as well. And oftentimes, those are all going to come together when you start talking about your modern data warehouse. And how these things start to come together is, naturally, some of those are going to be your dimensionality of of your facts that are much larger than they were in the past. Now, one of the things that the business first hits when they start to see this data is, wow, our tools can't handle this much data. How are we going to even start the journey of looking at this data when you get a multi-terabyte file or something along those lines that's in a JSON format? They're just stopped in their tracks right there. Now, how can I get started without IT involvement? That's, oftentimes the thought process. There's a lot of shadow IT. There's a lot of other things going on here. But naturally, that's not the best way to go about this, and it should be kind of a symbiotic relationship between the two. IT's perspective on this is really, we have a long project backlog, so we're busy. We're going to need a project for that, and oftentimes it may be funding from the business to do it. So what can you do to help us along this path? And didn't we already give you self-service tools? Shouldn't you be able to do this on your own? And I think there's a bit of a disconnect there because, naturally with some of these data sources, they're too big to just throw into your standard self-service tool. You need some infrastructure behind that to help you along the way. Now, I'm not saying you can't be agile in your form of getting there. You could definitely be very agile, to get to that method of getting that data through. And there's different ways you could utilize those self-service tools with slimmed down sets of data to allow them to start the process. Now, I'd like to cover some business use cases because I think, as I had mentioned before, is a big part of the way I like to tackle net new technologies is really understand how are you going to drive the most return on investment from this new technology. When you start diving into a new technology, obviously a lot of you are here today, you're trying to learn that new technology, you're trying to figure out how to use it. There's an investment from the company to figure out how to use it. Now, when you look at some of the cloud technologies, the investment is a lot less than if you have to do that in an on-prem fashion. But there still is skill sets that you're going to need in each of these services to be able to string all this together. So there is an investment. So you want to make sure there's a reason why you are tackling it with this new technology. And going at the business use cases is where you're going to show your return on investment to the business. And they will invest in this when they see this. Now, I'm going to hit on a few verticals. And I'm going to start with manufacturing. This is just one that I think is driving a tremendous amount of data. And in fact, they've been doing it for years. They were the original data lake. They had data historians in their systems. Those of you that have heard of Pi Server or Data Park or other tools like that that have been storing tremendous amounts of data. And I'm talking at the millisecond level where they're driving data through their factory pipelines. Now, I've been on those factory floors. A lot of what they look at is the rear view mirror. They're not looking forward. They're not doing predictive analytics on it. They're not understanding how their aging plant equipment is about to die at certain times. Those are all key things that are driving this change. And they've got a tremendous amount of data sitting there. So we could use that in a very interesting way. And when you think about the aging plant equipment, some of these things did not have sensors on them originally, but they are being retrofitted today with sensors. In fact, one of the plants I was in was, some of the equipment was from the 1920s. But they have some sensors that they've strapped onto these systems to be able to start gathering that data and piping it into their data historian systems. Now, the other thing in manufacturing that's kind of a different pivot here is think of devices that are being created. And sometimes these are your, did we ever think a refrigerator would be connected? Did we ever think other things were going to be connected? There's a lot of things that people are manufacturing today that are changing the way that they're going to be driving value to their customers. And I'm talking in almost anything that's manufactured that's in a consumer or a business's hands can be driving data, event data, just general data on what they're doing, marketing data out of that. Being able to being able to understand and figure out how to proactively look at maintenance and different things along those lines. So this is all huge changes in this industry. Healthcare. Healthcare is up for a major change right now. The data that was in healthcare was focused typically on patient visits. So it's when you basically went into a doctor's office, they hooked up an EKG machine, or did your blood glucose levels, or did some kind of blood testing. Any of that kind of stuff was a one-time thing. But now, when you start looking at the way that this is going, external feeds are going to change the way that healthcare is done. And some of us have seen this already a little bit with your fitness trackers. I'm not saying these are that HIPAA compliance and everything along those lines, but we start to see where things are going. Ultimately, the biggest change in this industry is paying for value instead of paying for service. When you start to look at this, paying for service means, let's say I had a heart attack, and within the next 30 days, are you going to monitor me, or are you going to just let me go about my normal routine? What happens if I have another heart attack in that 30 days? One, I'm paying for service there, because when I have the heart attack, that's when I'm paying. It's not while I'm outside the doctor's office. Paying for value would be much more important to me, though. I would much rather pay them to ensure that I never step foot in that hospital again for another heart attack. To do that, they're going to need to monitor my EKG. They're going to need to monitor my weight, my other statistics that are going to give them that detail. But all of this is going to drive tremendous amounts of data for them. Now, I'd much rather have my doctor call me up and say, I'm going to switch your medication. Can you go down to your local drugstore and get that new medication, instead of showing up at the hospital. Now, another big change for the healthcare providers here is that they're changing the way that they're billing now, because they're changing that billing process and able to actually start to understand the way that they could drive value in a different way. Now, if you talk about getting into a hospital within 30 days of readmittance, you're also not going to be able to charge Medicare for that visit. So that's a big deal for that hospital to ensure that you don't come back within 30 days. So there's a big change in the industry there. Energy. So the energy sector, there's so much going on here, and very similar to the manufacturing side, there's a lot of sensors and smart meters going in all over the place. Now, when you start to look through this, you're saving through better predictions. You're starting to be able to understand the throughput of energy production you need to meet with demand. And how does that meet up correctly? Now, you're also able to start doing some monitoring and managing of your pipelines to understand safety and health concerns of the people on those rigs, the people that are out in the field. There's a big concern when you get into the oil and gas industry to really make sure that there's a focus on safety. And that's something that's going to be helped quite a bit through managing and monitoring these sensors. Ultimately, they're going towards the complete smart grid and smart pipeline. Now, security, and I think this is an interesting one because it kind of breaks the norms of data. As we normally think of data, we think of text files, databases, even just messages that are coming across a pipeline. But in security, you have to start looking at things like video and phone calls and emails and other things that are coming through in these areas. So it really starts to break the norm of how you deal with these different topics. And as I get into some of the explanation later, I'll go into the reference architectures that start to show you how to dive into this data using things like media services to actually convert some of that data into text. That will allow you to take a video file and ultimately grab all of the text out of it. It also allows you, through cognitive services and media services, you could do motion detection, understand when something's changing in a screen in a video. These are things like, think of the police cameras that are on every chest of every police officer nowadays. How do you handle that much data coming through a system and being able to catalog, search, and also be able to do analytics on it? Because I want to be able to say, how often are these new slang words? How often are these new things coming into play that we could start to analyze and use forward. But you're quickly moving towards predictive risk assessment. And you're able to say ahead of time, this is what happened, move now. Don't wait 2 months later and look at the data and find out that something's changed. So this really becomes a real-time need. Now, the technical use cases, I'm going to boil some of these down, and I'll try to refer back to other industries as I go through these, because I think when you look at the technical use cases, they don't apply to just one industry. They apply to all kinds of industries when you go across this. Now, Internet of Things. So this is new data feeds that are just coming through in tremendous amounts of ways. So, you know, this is any device, anything that's driving data. So it could be your phone. It could be other things along the lines of manufacturing floors. It could be healthcare equipment. It could be almost anything that's connected out there in the world. In fact, one of the clients I just started working with is actually connecting their washing machines up to the internet. And this is allowing them to start looking at those washing machines to be able to really predict and optimize pricing of time of day and when people are using them, what area they're in. All of these things gives a lot of optimization on pricing. And just imagine what you could change in your bottom line as you start to tweak those settings on an hourly basis or something along those lines. It's also medical devices. So there's new blood glucose level testers where you could literally have a patch on your arm and it'll tell you your blood glucose level throughout the day. Those are things that are going to be tremendous for that healthcare industry to be able to change the way they do things. As I had mentioned earlier, almost any manufacturer is going to be able to change the way they do things with this. Old hardware and equipment could be retrofitted, as I had mentioned earlier. But the newer equipment is actually connecting directly into things like IoT Hub. And as you could connect directly into those hubs, that's really driving the ability to allow you to do real-time transactions through this whole system and through this pipeline. And I'll show you some of that as we dive further in the reference architecture section. Analytics are the driving reason for this. Bottom line. I mean, think of Fitbit. Fitbit, you know, has been around. What drove people to buy Fitbits? There were pedometers for years. You know, it's not that they are capturing your steps. It's that they're capturing your goals, your aspirations. It's changing the behavior of what you're doing. And you could apply this to anything in the IoT world. You're changing the behavior of what's going on through using the data to apply that to your business problem. So start to think of it in that way, because it's definitely changing the way you're going to be doing business. Data processing. So as I had mentioned earlier, a lot of the times the data that the business is getting in hands today are terabyte files. It's a social feed that they've been given from a new vendor that they're talking to for marketing. It's new IoT feeds. It's telematics data from the car sensors that are driving through any of the major car vendors. You know, the modern airplane just has a tremendous amount of sensors on it. You know, so it's all these things are starting to drive these new data sets that the business just has no clue how to handle. IT, a lot of the times, can't handle it with their existing infrastructure and hardware because you're already using that ETL server or whatever it is to pretty much max out in a 24-hour period of what it could do. There's other organizations that I've talked to that ultimately have massively parallel processing engines on-prem that can't scale anymore. How do they get to that next level, and how do they do staging of data and different things in that area? So all of this is huge, huge changes are coming in the way that people do things. And when you're talking file-based processing, Hadoop is a great engine for this. And all of that comes inside of HD Insight, inside of Cortana Intelligence Suite. Ultimately, it's allowing you to, when you start thinking of this in data processing forms, though, it's leveraging Cortana Intelligence Suite to quickly load up data, transform that data, cleanse the data, and move it through. And there's a number of different tools that I'll get to when I get to the entire catalog of services to show you which pieces are going to help you with this process. Because it really depends if you're doing real time or are you doing batch. And where do you want to live in this process? And do you want to tap into skills that are available in the industry today? When you're going to hire people. Those are all important things that you want to leverage in these systems. But ultimately, this is removing roadblocks really quickly. So if I could spin up a new data set, for instance, a telematics data set that may be many terabytes of data quickly, what I could do is give a sample set of that to the business and get them in their self-service tools to start working on this data. Now, I'm not going to give them the full data set in that case, but I'll give them a sample of it to get started. And it's easy for me to get that iterative process going with the business quickly, and then they could come back with a real project plan of saying, okay, well, we looked at the data. Here's what we see in it. We think it needs to be joined with XYZ data. And when you start talking about your modern data warehouse, this is how things start to come together. It's the big data pipeline coming through, using that as a staging environment, and then joining it together with standard dimensions you already have in your other data. And that's where the business could start to see that process and help you through it iteratively. Now, predictive learning, and like I said, this has been around for years, but mostly it was done in SAS, SPSS. People were using R for many, many years. These are all things that people did, but most of the time it lived on a single server or a single workstation. And you can't scale when you get to that level, especially when you get to the sizes of data that we're seeing today. And really, the predictive learning lifecycle is important. When you really think of predictive learning, it's not just, let me use an algorithm and put together a model. It's usually a lot of data cleansing that happens prior to that. I've talked to many, many, many data scientists over the years. One of their biggest challenges is they have the mathematics background and everything to do all of the really intense data modeling. But how do I get this massive data set fed in and usable for me inside of my tool sets? And that's a big part of what that predictive learning lifecycle is going to focus on. The last part of it, though, as well, is once a data scientist has created a model, how do you productionalize it? Many times in the past it was, they would use SAS, SPSS, R, different things to prototype the model, and then they'd write an API or a web service using Python or some other technology. Now, when you started to do that, that's extending that development time frame quite a bit. And one of the reasons why I'm showing you a demo really quickly today of Azure Machine Learning is what it gives you in the end of this. Not only does it give you a great cleansing and kind of data pipeline process to get it to the point where you need to, but it also takes it and gives you a fully documented API at the end of it, which is a tremendous value to be able to hand that to one of your web developers or system developers and say, here you go. Just integrate this into the next, save of a data a record in your system. But the ultimate reason that this is important is that it's steering the ship while you're looking forward, not looking in your rearview mirror. As I had mentioned, with data coming from data historians in manufacturing plants, they're pretty much looking at point in time up to right now, but in the history. There's nothing forecasting what they should be doing in the next 10 to 15 minutes to change how that plant floor is going to work. I mean, if they could be notified a few minutes before a breakdown, they could shut it down, fix it properly without having a catastrophic repair. And you're talking hundreds of thousands, if not millions of dollars when you shut down these plant floors. So to be able to have that insight is just tremendous value to them. So what is Cortana Intelligence Suite? I know there's a lot of buzz around this, so I think one of the things I'm kind of taking a slide from Satya's keynote at the beginning of this. This is really focused in the services area of this slide. This is democratizing AI, allowing you to use these tool sets And some of these pieces ultimately are the breakdown of the Cortana Intelligence Suite right here. Now, when you look at this, the far left and the far right essentially have all of your data sources, apps, sensors, devices. These are the things you have in place today or are being built today in your environments. Could be in the cloud, could be on-prem. It doesn't matter. This is easily accessible through Cortana Intelligence Suite, either way. And I'm going to actually show you different reference architectures as we go further in this session. Once you get into the blue boxes in the middle here, this is where really the Cortana Intelligence Suite sits. You can buy this as a single SKU if you intend to use a lot of these tools. You could also buy it individually, a la carte, and come in and say, I just need this service and I need it for X amount of time. I'm going to turn it on and turn it off, all in an automated fashion. There's certain pieces that you naturally can't just remove if you need your data to stay there all times. You need that blob store or that data lake store up and running. But there's a lot of pieces that you could scale up and down as you need. Now, information management is really focused on data factory, data catalog, and event hubs. Now, IoT hubs is not mentioned here. That's part of the IoT suite, technically. But event hubs and IoT suite are very similar. There's certain differences, you know, in those two, and there's a lot of great articles and a lot of things online to go into detail here. But an ultimate difference is you're looking at the number of protocols that could write directly into the hub versus, you know, and it's kind of that million to 1 point versus just a few to 1 point. You know, and if you think of a few to 1 point, event hub is the spot. If you talk about millions to 1 point, that's going to be more of that IoT hub. If you're having your devices write directly to the hub, you're probably going that route. Now, Event Hub is it's basically a queue. It's going to grab all your data and let it sit there, and it allows you to interact with it in real time. So this is something that you could also, later on as I get through into Stream Analytics, you could temporarily query this data. It is not a permanent store for your data. It's something that it's a queue, and it will clear itself out after a certain number of hours, days, so on and so forth. So you do have to actually manage that and move it elsewhere. Now, Data Factory. Data Factory is a tool that essentially allows you to do ELT, extract, load, and transform. Now, what this allows you to do is do it in various tool sets that I'm going to explain as we get further along here. And actually, through some of my reference architectures, I'll show you each of these tools as they go through this. Now, with Data Factory, it allows you to connect to on-prem sources. It allows you to connect to cloud sources. Ultimately, think of this as your source and your target for those of you that are, you know, ETL folks in the room. That's your source and target. There's transforms along the way. There's copies of the data being moved along the way. But essentially, this allows you to move that data through a pipeline. And it allows you to do it in a batch-oriented way. So if you're looking for batch processing, this is probably the way you're going to do it using this tool set. Now, Data Catalog, this is an amazing tool. So the more and more we spread out and we have more data feeds and more data sources across many different divisions of your organizations, when you start to think of this, Data Catalog is a way to start to catalog all of those different sources everywhere they're sitting. It could even be staging sources or things that are moving through a pipeline. You could be managing those as well. And this allows you to have a single interface to search and find all the metadata. This is the data liaison's dream, you know, to have this tool and have it connected to all their sources. It also allows you to connect through using Excel, Power BI, and different other tools to those sources when they're cataloged properly. It'll even give you profiles of what the data looks like. It'll even give you descriptions of the data fields. If they're in the data source, it'll try to pull it from it. If it's something that's not a standard kind of relational database source, you're going to actually have to type that in, but it also could be managed by different data liaisons. Doesn't all have to be managed by IT. You give the access to the different end users and you let them manage that. And they could document everything and you could make different people owners of different data sets. Now, in the big data stores, There's two of them listed. There's Data Lake Store and there's SQL Data Warehouse. Now, I would also venture to say that blob storage is also another area that you could use. So, you know, it's another tool set very similar to Azure Data Lake Store. There are its differences as well, though. And there's reasons that you're going to go to Azure Data Lake Store, as the gentleman in the last session really highlighted. Security is a big part of that. And it allows you to do quite a bit with security, and that is a key differentiator between the two. Now, Data Lake Store is more of your, think of this as your HDFS layer for those that are Hadoop skilled. You know, HDFS, it allows you to essentially have a massive storage system for your data. Now, SQL Data Warehouse. This is an MPP system for those, it's massively parallel processing. So what massively parallel processing does is it allows you to essentially have multiple nodes querying the same data set, but it distributes that data across multiple nodes. For those of you that have been around the Microsoft ecosystem for a while, think of this as your parallel data warehouse or your APS appliance. This is ultimately the Azure equivalent to that tool set. But there's big differences with this tool set in the sense of how I turn it on and how I turn it off. I could turn it on and pause it at any given time. And I'm going to actually show you a little bit of that in my demo. You could pause the system, and within minutes, it'll pause or unpause. You don't get charged for compute during that time, which that's a huge differentiator. You're paying for your storage space, but not your compute time. So it's that disconnect that they've done in a lot of their other services in Microsoft as well. That's what they did with HD Insight as well. HD Insight, they broke apart the compute and the storage, which is a huge differentiator as well. So machine learning and analytics. This box, ultimately, machine learning naturally, that's one of the tools in here, Azure Machine Learning. I'll do a really quick demo of that as well. Ultimately, this gives you that ability to create machine learning models very rapidly. One of the greatest things that Microsoft did in this tool set that I really love, they brought the ability to extend it with R and Python. So, and the tool set was already very impressive when they first rolled it out, and the documentation and the templates that they rolled out were awesome. And I'll show you a little bit of that as well. But when you start to look at this, especially when it first came out, there were certain things that you couldn't do feature selection comparisons, you know, that you would easily be able to do with some R code. There's other things that you could do with Python code, but they initially released it with that R integration. And there were the ability to essentially feed a data set in, put some R code on top of it to do some quick transformation, and then spit out a data set on the back end of it. So you were able to do some of your cleansing or slimming down of data in using R. You also were able to reuse your R models inside of this as well. So that was a huge differentiator for them in this system. Data Lake Analytics. So this is where you could spin up your analytics stores on top of this and run it per job. There's SQL code that you could use underneath this to basically give you the ability to run batches and only pay for the job. So you don't necessarily always have to pay for a system to be on at all times. So it's a slightly different way of approaching this, and I think it's a very interesting way to do it. And you know, it's a little different than you'd use SQL instead of using something like Hive if you were to go with Hadoop. But that's kind of the differences between some of those. HD Insight. So this is your Hadoop environment. So for those of you that have used Hadoop or anything in the Hadoop ecosystem, ultimately Hortonworks HDP is what lives inside of here. There's some slight changes to allow them to be able to connect to blob storage or to connect into Azure Data Lake Store. So there are certain investments that Microsoft is making to that suite to make it more extensible for the cloud and capable to be used in the cloud. Now, there's quite a bit that can be done in here, and the other benefit of using a standard Hadoop variation, there's not a lot of people, but there's more and more people that know Hive, that know Storm, that know how to use these different tool sets. And more as things keep moving forward, this is something that people will learn more and more of. And it's more file based than it is working with something like event hubs and stream analytics, where it's more single records spinning through the system. Stream analytics. So this is a really neat tool. This is kind of your CEP engine that helps you, really run data through in real time. But it is so simple. You basically set up an input, and that could be blob storage, or that could be an event hub or an IoT hub. And then on top of that, you read that data through, and you basically set up select statements on top of the data. But in your select statement, you get to add a little snippet for temporal feeds. So you could just take the raw data and pipe it through and do something with it at the back end. The back end outputs include things like Power BI. It includes writing to blob storage. You could also write to another event hub. You could even do machine learning API calls in the middle of this to be able to add some compute to the center of it, which is also a very interesting way to handle this. Now, with stream analytics, one of the other really neat things that people are using this for is the temporal queries. When you start talking about millisecond data, it's flowing through so fast that it's like looking at a river and trying to analyze every particle of water that's coming at you. It's nearly impossible to do so. Now, what you can do with this system is you could start to aggregate that and say, everything that's passed by in this square foot of water, let's aggregate that up. So you could start to say temporarily, let's look at the last 15 minutes. And this could be in different windows. You have different types of windows that allow you to look at it in different ways for just the last 15 minutes, or maybe every 5 minutes for the last 15 minutes. So it's things like that that you could output just those aggregate records to another source. A lot of the times you'll combine that with writing out to Power BI to be able to analyze and do alerts on real-time data coming through your system. And I'll actually show you that in one of the reference architectures. Check my time here. Okay. So now over on the intelligence side, you've got cognitive services, and they've been making a lot of investments in this area recently. This, ultimately started with facial recognition, emotions, different things along those lines to help you integrate APIs that they've used in other tool sets, but now they're surfacing them for you to use in your own tools. So this is a really interesting area of development that Microsoft is going into, and it's really allowing those custom developers to take some of that power of what Microsoft has done and reuse it. So you've got your bot frameworks that are underneath here. And those are fairly new coming out as well. And you've seen probably some of the demos and things that have been done on stages around those. Cortana, which allows you to start doing voice interaction with your tool sets. So for instance, you could now interface through Cortana into your Power BI data sets. This allows you to query for what are my sales for the last 3 quarters for this region. And it'll pop up a chart for you. And it'll start to use that natural language search to be able to bring that all together and help you understand how to utilize that data. And then naturally that dashboarding and visualization layer, and this is what the business really cares about a lot of the times, is that show me what it is, show me the end goal here. But a lot of the times to get what they want in an end goal, it takes a lot of the stuff that I've already talked through here. And it's just different ways you're going to put these pieces together for the different use cases you're going to focus on. Another interesting part of Power BI is it has real-time alerting that could come out of that system. If you set it up properly and have the stream analytics flow data directly into that, on your mobile phone you could set your own KPI thresholds and say, here's when I want to be alerted if this happens. So it'll start to allow you to take that real-time event all the way from beginning point with might be a data sensor or some other point, all the way to that end user getting notified that they need to do something right now. So I'm going to jump into a brief demo. And a couple things that I'm going to cover here for you. For one, obviously I've got a resource manager, a resource group pulling all of this together. So it's a few of my different things that I'm going to go through in a demo today. First off, I have the HDI, the HD Insight cluster up and running. Now, one of the things I wanted to show you here was, and let me make sure that I'm connected. Yep. So I mentioned scaling clusters. So with HD Insight, if you need to take down your cluster completely, you probably want to automate it using something like PowerShell. You could literally create it and destroy it all through a PowerShell script or through Linux shell scripts. Either way. With the CLI, you could do that as well. But if all you're looking to do is manage the amount of nodes in the system, because maybe at nighttime you still want it up and running, but you don't need to compute if you're a regional company that you would need in the middle of the daytime when everybody's hitting this thing. Or maybe it's during your data processing time. You need to scale this thing up or scale it down. Now I'm showing you the interface here, but all I have to do is literally put a new number of nodes, save this, and within about, I think it's about 10 minutes or so, don't quote me on that time, but you know, it will reset that cluster and essentially bring up more nodes for you to use underneath the hood. Now, you still connect to the same head node. Everything's the same in the sense of your code. Nothing changes there. But it does allow you to automatically scale up and down. For those of you that have used Hortonworks, the Embari dashboard is part of this system. This is directly off of that HDI cluster. In fact, I could even go in and run Hive queries or things like that if I wanted to. Browse the data in here, things along those lines. You could do that in the normal portal, but if you're hiring people that are used to using a Hortonworks cluster or another type of cluster, they may feel more comfortable in this dashboard. Now, another thing I wanted to cover is your SQL data warehouse. And I'm going to just let that go because I don't need to change the cluster size here. Now, this one's even more interesting because this is SQL data warehouse. Okay, so SQL data warehouse gives me the ability to start my cluster, so I could start it. I could scale my cluster. And right now, since this one is not started, or actually it is started, so I could actually go in and change my data warehouse units on here. And this is what I was mentioning about scaling kind of the number of nodes behind the hood. They use this more in a horsepower terms. Think of it as data warehouse units. So the data warehouse units is ultimately relating back to the amount of horsepower behind this system for you. And you will get exponential growth on that up to a point, and then it is linear. Just depends on how the data is separated, how large your data set is. There's different items there, but you are seeing tremendous value in this if you have large data sets. And this is the way you're going to want to handle that. Now, the other benefit is I could start and I could pause this system. So if you know that people are only using it between 9 and 5 or something along those lines, or you're only loading your cubes or other things from this data at an automated time at 2 in the morning, you could use this system at a really high scale in the middle of the evening and while you're doing that, and then you could scale it back down. So you could look at that, and all of that could be scripted. All of it could be done through PowerShell or CLI scripts to be able to do all of this. So it's all a very interesting way to handle this. I could open it in Visual Studio. I could even open it in Power BI. So if I click this, it'll literally open up a Power BI connection directly to my Azure Data Warehouse and allow me to start generating a whole model that goes with that and a whole bunch of reports that go with that. You essentially connect to this just like you would connect to your standard SQL server. It's very similar. You use the same server settings. It's just you've got a DNS that lives in the cloud. The server name is a Windows.net domain, so it's slightly different. But both of these systems could be connected through using your AAD, which is your Azure AD. So if you've got everything set up in your environment to handle that, this would be just an extension of your data center. So there's not much different that you'd be seeing in the sense of using this if you had a parallel data warehouse on-prem versus having this in the cloud. But your scaling of this is a big difference. Now, another area I want to cover is Azure Machine Learning. So again, I'll just cancel my edits here. Azure Machine Learning is now integrated into the new portal, and it allows you to go ahead and click into your launching of Machine Learning Studio. I could launch Machine Learning Gallery, and I'll try to show you each of these. And you've also got launching Machine Learning Web Service Management. Now, this is an amazing field of work that Microsoft has put out, in my opinion. They've done a really good job here. Now, I'm going to go into my experiments first, and I'm just going to start from scratch. I'm just going to really quickly do one here. With this, what I'm going to do is I'm going to look at a breast cancer data set, and it's a sample data set. It's a very small data set. There's a reason I'm doing a small data set, because it does take some time to run these processes if you have a massive size of data. So I don't want you all to be sitting there watching something spin on the screen. Now, what I'm going to do is I'm just really quickly going to run through this demo and create a model for you. So inside of here, I've got saved data sets and I've got samples, and I'm just going to go to my breast cancer data. So one of the first things I could do, and normally if you're connecting through to a CSV or a SQL server or other sources of data, blob storage, you're going to have to run it first one time, because it'll load the data in cache for you. Then you've got those fields and you're ready to start working forward. In this case, since it's a saved data set, it's already in cache. So it's ready to roll. Now, I went on that and I was able to start looking at the data. I could see my classes, my age, menopause, tumor size, different features that are getting added into this model. Now, this is a clean data set. I didn't want to go too into detail of showing you how to cleanse data. There's a tremendous amount of features in here to be able to do that. Now, I'll just scratch the surface here, but as you can see, as I click on each of these things, you get some really interesting statistics over here, and it's profiling all that data for you. So it's starting to tell you, is this data clean? Is it not? Does it have missing values? Does it not? Garbage in, garbage out means more here than anywhere. You do not want dirty data coming through when you're creating machine learning models. Now, one of the first steps I'll do is inside of here, let me go back to that, sorry. Inside of here, you've actually got, all of these are listed as numeric feature currently. I can actually change some of those features and play with them, but one of the first things I'm going to do is do a little bit of data cleansing, and I'm going to actually create data transformation here. You could also search for things if you know the specific names. It'll pull it right up for you. But inside of here, the first thing I'm going to do is actually do some manipulation. So inside of here, you could join different data sets together. You could actually apply a SQL transformation if you wanted to do SQL transformations, if that's where you typically live. But in this case, I'm going to actually just edit the metadata. And what you do is you just drag that forward, and it basically brings the data set forward for me. Now, inside of here, I want to edit the metadata. And what I'm going to do is I'm going to actually select the field that I want to edit. And in this case, I want to select class, because that's my classification. That's, do you have breast cancer or do you not have breast cancer, essentially. So I'm trying to predict that ahead of time. Now, inside of this, the first thing I need to do is actually change that classification to a label. Now, with that, what that allows me to do is that's what I'll be predicting in my model later on. So I'll continue on with this, and essentially, at this point, since the data is relatively clean, I don't need to manipulate the data too much more or filter it or do different things on it. So what I'm going to actually do is start to set up for the model itself. So at that point, I'm going to go into the sample and split, and I'm going to split this data. So I could bring that down, and essentially that brings that data set forward again, and ultimately it creates two data sets. If those of you that know machine learning, you've got a training set and you got a test set. You're trying to see how good you did. Now, inside of here, I could set this to just a 50-50 split. I could also do things like stratifying the split on a certain field, saying this is an important field and we don't have many that are a yes, so we probably need to stratify the split and make sure that it actually separates the thing based on a certain key field. In this case, I'm just going to leave it as is. My next step, ultimately, at this point, is now preparing for my model. And in this case, what I'm going to do is start going into the machine learning models. So inside of here, I'm going to start with initializing my model. And this is a classification. I'm trying to classify a yes or a no, essentially. And what I'll do is I'll take a two-class classification, and you could drag this stuff out. What I'll do is I'm just going to start with, let's say, a decision jungle. And inside of here, inside of here, this will actually go towards the trained model. So I'm going to train it with the trained model. Now, what I'll do is I'll take this data set, which is 50% of my data, and I'm going to also take the algorithm that I'm pulling in here to start to train the model itself. And ultimately, I have to pick, well, what am I going to train it on? And in this case, I'm actually going to train it on class. So in that trains it on class. And now what I'm going to do is I'm going to score the model. So the scoring of the model is going to take the trained model in, which ultimately will be something you'll use in your API later, if you like what you've done here. Now, you could also go in here and customize these a lot. It gives you kind of a default, but if you want to go in and figure out the maximum width or depth of your trees and your models that you're working through here, you could go in and do whatever you'd like. And a lot of the data scientists that I've worked with really love the capabilities that you have to dive into this detail. Now, at this point, you're pretty much ready to go, but there is one last thing I want to do here is evaluate the model. So what that'll do is it'll start to show you, so I'm just going to leave it as the default experiment created 921, and I'm going to go ahead and run this. Now, this is the first step of creating a model, but you saw how quick that was. If I like my results, it only takes a few more minutes to get this to an API where a developer's using it. And I'll show you those APIs in just a minute. But this runs really quickly. Now, in this case, this is a small data set. So I'm going to be honest with you, that's not going to run that quickly if you've got a massive data set in here. But one of the things you'll be able to see is I can start to visualize this data. Now, naturally, this is a clean data set. So you're getting really good predictions. I would not expect that to be that good in your normal data sets that you're going to be using. But if you could get better than 60, 65% on your scoring in the accuracy and the precision, you're doing really well. And in this, you'll see that you've got your confusion matrix with your true positives, your true negatives. What's my positive label? What's my negative label? That could be a yes, no. It could be a 1, 0. Could be different things along those lines. You could see I was accurately able to predict true positives of 111, true negatives of 215. I had false positives, which were inaccurately saying it's false, or saying it's a positive classification. I also had 8 negative that were false. So those are ones that are bad predictions, ultimately. So, and you got to balance that with the model you pick, because sometimes you're going to choose more false negative versus false positive. You don't want to give people bad news about cancer if it's not true. But you also don't want to miss somebody that has cancer. So there's a balance here that you have to make. So ultimately, this would be a model that's done. Now, all I'd have to do is basically hit this set up as web service, and that's going to run through and create a web service for me. Now, I'm going to show you. See, it changes the screen a bit here. I should have left it on there for you. It changes that for you and ultimately adds in the web service endpoints for you. It does different things in that model. And it also creates a trained model out of the pieces that you were putting together. The trained model part and the algorithm combined to make that published model. Now, at this point, you're ultimately going to be at a screen like this, where this is where I showed you there was a different service button inside Azure portal. This is a different service, the web service area, which is the new web service area for Azure ML. Ultimately, inside of here, I could go into the breast cancer web service that I created. I could test the web service right here. I could look at my documentation. I could submit requests. Imagine how long this would have taken for a developer to put all of this together with documentation. Let me add, a lot of developers don't like to document things. But I could even go in here and I could test my data set. You, in fact, could grab an Excel file to do batch testing. All of this is done for you in a few minutes. So it's really amazing the way that they've built this out. Now, one of the other things that I'll quickly cover here, so I can get to the reference architectures, is look at the Cortana Intelligence Gallery. There's all kinds of stuff in here. In fact, there's all kinds of recently added ones and different things that focus on your business. So it's a great way to get started, and any of these are pretty much areas that have documented areas that you could go into, and it says, this is what I built, and here's how it works. So it's really neat that they open sourced all of this to everybody. So let me jump back into reference architectures, because I think this is probably a really interesting part of the segment for everybody. So new connected devices. So think of this as IoT. When you think of a new connected device being added, the first thing that I mentioned, that device is going to be connected, and if it's web-enabled or IP-enabled, it's going to be able to write straight to the IoT hub. If that's the case, that's your most direct route, and it's going to be directly into the system. Now, at that point, you could use Stream Analytics on top of this to do those temporal queries. You could move the data through the system, all in real time. It allows you to use machine learning in this process. This would be the API that I just showed you. It would be using that API in a real-time request response mode. Now, the data lake store would be your output layer for dropping data to live long-term, okay? Now, that data may live in a long-term area, but think of Fitbit and the analytics they're going to want to do on their customers. One of the really interesting things they may look at here would be how many customers are using my device yesterday? And I could do a temporal query over that 24-hour period to see if they have a step. If they have one step, they're using my device. So now I could start to do analytics on that on the back end. Data Lake Store would typically be queried through HD Insight using Hive. So you could start to query that data and pull that data out. You could also connect Azure Data Warehouse on top of this to ultimately use Polybase to query that data. And that's a way that you could start to query the facts and the details at the lowest grain. Now, you may actually aggregate it up as you take these last 3 hops. Data Lake Store may store all millisecond data, something along those levels, whereas you might get to HD Insight and Hive, you may do a transformation in there to actually start to load up by day or by minute or something along those lines. And once it gets to Azure Data Warehouse, maybe you just store in Azure Data Warehouse, like in a table in Azure Data Warehouse, would be the aggregated data. But you could also have a Polybase table set up to call that data underneath it to allow you to get to the millisecond level data if needed. But you don't have to store it in Azure Data Warehouse at that point. Now, naturally, Power BI can connect through to this, and also Power BI embedded. So think of this, most things that are IoT devices have a mobile app that goes with it. That mobile app has a lot of charts and graphs. Wouldn't it be great to already have a pre-built system that does that? And you've got that in Power BI embedded. Power BI embedded will allow you to connect through to Azure Data Warehouse, Spark, if you want to use HD Insight directly, or SQL database. All 3 of those connectivity points are capable through the embedded Power BI use cases. And I'll show you in another spot where it gets into a real-time nature. So predictive maintenance, and this is that real-time kind of area. So this is a little different. This is not where you're going to connect directly to an IoT hub or an event hub, because it's micro batches. So it's near real time. It's not quite real time, but it's every 3 seconds. So when you think of a data historian system, it takes a little bit of time for it to write into that system. Then what you could do is have a web job sitting on top of that to query the ODBC drivers or the JDBC drivers underneath that, and be able to start to call micro batches on an every 3 second basis as well. Now, those micro batches are going to drop into blob storage. Blob storage is storing, like I said, every 3 seconds you're getting a new feed. So this is really close to real time. Not real time, but close to it. Now, Stream Analytics could look over blob storage. You could still do temporal queries as long as you have a date time field in there. And Stream Analytics could then use machine learning to be able to say, where are my troubles coming? in the next 15, 20 minutes, am I going to have this system break down? You know, and obviously there's a lot of information that's going to have to go through the training of this model and everything in that side. And if you look at the data lake store, that's one output. The reason I'm outputting it to data lake store here is mostly for retraining the model. So after it goes through data lake store here, HD Insight could be called directly from machine learning for retraining your model. This is not to do a scoring of your model. Your scoring of your model would be done through stream analytics, you know, using it to score a micro batch. But when you go through data lake store and up through HD Insight and back to machine learning with the dotted lines you're seeing here, what that is indicating is essentially you're spinning up HD Insight to be able to tap into data lake store and run a Hive query to pull in new training data. Because on a weekly basis, you may update your model, you know, to have the newest information. You may also throw away really old data and to get it out of that model, because it might be dirty at some point where you say, you know, we've had a change in process or something that has to adjust to it. Now, you may also load from HD Insight into Azure Data Warehouse for more of a long-term queue of storage. But I think the most interesting part of this architecture is coming out of Stream Analytics and going directly into Power BI. So you'll see that Power BI has two inputs. One is Azure Data Warehouse, and one is Stream Analytics. Stream Analytics is going to give you your real-time data flowing through. You may even do some temporal queries on this. Now, one thing that I caution people, as you're writing directly to Power BI, you're also flooding it with data that will probably go past its limitation in data sizes at some point. So, because it's writing to a Power BI data set. Now, if you're going to do this for a real-time flow, you will probably have to, through the APIs of Power BI's data set, you could actually destroy that table and rebuild it using Azure Data Warehouse. So there's a little bit of a custom code you need to build here, but every once in a while you'll have to purge the real-time data coming through. Outside of Power BI, when it starts to feed back to your app service or even your Power BI mobile app, this is where you could start to have your alerts. Shut down this machine right now and have it ping everybody on the work floor. So those are things that are huge for a predictive maintenance flow, to be able to have that real-time feed. Event data processing. So there's some similarities between the next three slides that I hit here. And what you're going to see is you've got data management gateway, and I'm going to just fast forward through some of this. Is you've got data coming from on-prem. That's the dark blue on the far left side here. Now, data set source this could be a JSON file. This could be an XML file. It could be a flat file of some kind. You're going to have a data management gateway sitting in the middle here. That's ultimately from your Azure Data Factory, Azure Data Management Gateway. What that allows you to do is start to look on-prem on your file systems and pull data to the cloud. There's a copy activity that happens to drop it into storage blob. Once it drops into a storage blob, I can now spin up an on-demand Hive cluster. It'll create the cluster and destroy the cluster as part of my Azure Data Factory flow. So in doing so, I only get charged for Hive and HD Insight for that long. You know, it's as long as that process is running. At that point, it'll drop that data back to blob storage at the end of my Hive statement, and now I could load it into wherever I want. So this is where you're going to do transformations, different things where you're adding value to your data. It's different processes that you might have that are in your ETL flow. Now, at the end, you're going to drop that into your data warehouse, and that's where it'll live for a permanent level. Now, when I say pre-aggregated data, what I mean by this is you may aggregate the data from millisecond to minute or something along those lines and then put it into Azure Data Warehouse for people. It just depends on the business case here, you know. Now, let me show you another example that's very similar to this, but this is queryable details. So it depends on how big you want to scale your Azure Data Warehouse, is what it comes down to. Now, same thing goes here as the last one, but it's a little simpler of a process because you're not doing that Hive transformation to aggregate the data. What you're doing in this one is you're taking the data from the data source, you're using the data management gateway to copy it over into your data sync in Azure Data Warehouse directly. So Azure Data Factory manages that entire process. And at this point, you've got queryable details directly in your Azure Data Warehouse. So at this point, now your size of your Azure Data Warehouse is going to be bigger, though. So it's trade-offs. These are the things that, as a consultant, I always have to remind people, it depends. What's your scenario? I want to make sure this is cost-effective for you. So hybrid data processing. Same process, but let's say my end goal is to get it back in a database on-prem. Perfectly fine. I could run all of that using Data Factory. So Data Factory will allow me to take my data source, use the data management gateway, drop it into blob storage. I could do transformations inside a Hive with an on-demand cluster. Do whatever I want with that data. Now, the benefit of using Hive for these kind of things, I don't ever load it into a database. So the speed is a lot quicker. I'm doing it all through flat file transformations. It's reading from a flat file, it's dropping a flat file. So ultimately, there's no loading into the structure here. Now, it drops out to a blob storage, and then ultimately that blob storage will be a data source as well. It will then go ahead and write that data back through the data gateway into your on-prem database. So ultimately, your data gateway is kind of that hub going back and forth here. And this we're seeing a lot because people are running out of space in their data centers. So again, Data Factory comes into play here, and this is Predictive Analytics Cloud Batch. So this is saying, I've got some data that gets dropped on-prem, but ultimately I want to take it and use it in the cloud. So what you're doing with this one is you're grabbing the data source, you're going through the data management gateway. This could be any SQL server that you've got data in. What I'd do is pull that through, drops it into blob storage. I could use an on-demand machine learning transformation inside of Data Factory, which basically will spin up it'll call the API ultimately to use, and then it drops it back into a storage blob. That's dictated based on the way I write my Azure machine learning model, because I could have a data output here. And then in the end, it's copying anything that's been scored in data into my data warehouse. Now, I may have other flows that are actually pulling data directly in for dimensions and facts and other things that I need for that data warehouse. But this is showing you how you could actually do your machine learning scoring in that flow. So, predictive hybrid batch. So this is, again, very similar. Difference again here is I'm using on-demand machine learning transformation, but I'm able to write it all the way back. That's the big difference. At the end of this, I'm writing it all the way back to my on-prem database. All of this could be automated to be running in a 15-minute cycle if I wanted it to be. So it just depends on how you're going to set up your processes, but you could do this and use Cortana Analytics and Cortana Intelligence Suite even for things that just normally sit directly in your SQL Server on-prem. Now, this last one is kind of where the cognitive services is going and AI is going. Think of this as web application could be anything. So it could be the Uber app. It could be where they're recognizing a person's face and making sure it's the right person that's logging into the system. It could be things like text analytics or speech recognition. All of those things are in that cognitive services area. But it also could be your machine learning APIs. Where you see this quite a bit is when people are looking at their CRM systems and saying, well, will this customer buy from me or not? There's a lot of history to that data that you could be looking at. And you could be putting scoring in there to let your sales team know which to focus on and which not to focus on. If they have a 90% likelihood of closing this deal, they should get some attention. If they got a 30% chance of closing this deal, they probably shouldn't be. Now, those opportunities are changing rapidly. As those changes are happening, they could be scoring in a request response to the API every time it's changed to rescore that record. Now, at the end of or at the beginning of every morning, you should say, that salesperson could look at their dashboard and see what their top focus should be for the day. That could all be built directly in their CRM system. There's no reason that this can't go together, and we've seen it together in numerous cases already. So ultimately, the moral of the story is we're better together. When you look at IT and business, the business has some very interesting data coming their way today. And they need help to get it there. Just giving them a self-service tool is not going to do it. But that's not the way that they're going to say, okay, we're done, we don't need any more projects from you. No, you need to give them the infrastructure, you need to give them the capabilities they need. And is that for real time? Is that for batch-oriented? Is it for structured? Is it for unstructured? Those are the types of things, but it doesn't always have to be this massive project to start with. You could spin up these systems pretty rapidly in more that proof of concept mode of getting the data to an end user so they could start the iterative process. Let them start to play with it, understand what they're working with, then they could come back to you with a more official project plan. Because that's the way that iterations and the kind of agile process is going to work with the business. So call to action, I can't stress enough, gather your business use cases. This is something that I do with a lot of people I talk to. Understand what your business use cases are that apply to this. If it doesn't apply to this, don't use big data. Don't use things like that. Use your standard relational systems. Use a SQL database. Use a SQL DB in Azure. That's fine. But if it does require this massive size, look at these other systems. Understand the value to the business. Start to create your own kind of scoring on this. How valuable is it? And make sure it's a senior executive kind of saying this, because otherwise everything is going to be a 10. So, and then determine the ease of building the solution. And it could be phase 1 versus phase 2 versus phase 3, but how easy is it to build, and start to give them kind of a view of where should you focus first, because that's really ultimately the way you're going to want to do this. Please give me feedback if you liked what you saw here. And I'll leave this one up last. I think you guys probably know how to get to the evaluation side. Anybody need that? I'll leave it up. So I want to give you, I left a couple minutes at the end here for questions. Anybody have any questions or anything they wanted to ask? If not, I'll be here for the next 10, 15 minutes. Feel free to come on up and talk to me. Thank you so much.